Welcome students. So in today's session we will be discussing about the instructions that are grouped under the logical instruction set supported by 8051, and where we have seen that the peculiarity of this particular instructions that is grouped under this instruction set is that it performs the operations on an 8-byte data, but it on a bit by bit basis. Okay, so each of the bits of the two operands will be underwent the particular operation. That is, if you are performing a logical AND operation, the D0 bit of the two operands will be undergoing a logical AND operation, and the result will be updated. Okay, likewise a bit by bit operation is performed, but the instructions are basically concentrating on performing the logical operations on an 8-bit data. So the first instruction that you can include in this, that is included in this logical instruction, that is the logical AND operation, and we have the general syntax AND destination comma source, which means the data that is specified, the data content of the source location and the data in the destination location specified by the instruction is will be undergoing in logical AND operation bit by bit, and the result will be updated to the destination. Okay, and during this operation the flags are also affected. Okay, so let's look to the examples. ANL a comma hash data means the immediate data specified in the instruction and the content of the accumulator will be logically ANDed, and the result is updated to the accumulator register. ANL a comma RN means the content of the register specified and the content of the accumulator register is logically ANDed, and the resultant is updated to the accumulator. Okay, and then ANL a comma direct means the content of the memory location specified in the instruction and the content of the accumulator register is logically ANDed, and the resultant is updated to the accumulator register. ANL a comma at the rate RI means the content that is pointed by the pointer register is fetched, and that content is logically ANDed with the content of the accumulator, and the resultant is stored to accumulator. So the first four cases or the first four instructions are the most commonly used instructions, where you can see that one of the source is always the accumulator, and the other so operand can be either from an immediate source, or it can be some value mentioned through the direct addressing mode, or it can be through the register addressing mode, or even it can be through the indirect register addressing mode. Now we have the another two possible combinations or possible instructions, that is ANL direct comma A means the accumulator content and the content that is available in the memory location specified in the instruction is logically ANDed, and the result is updated to the memory location that is specified in the instruction. And we have the last one, that is ANL direct comma hash data, where the immediate data and the content of the direct memory location specified in the instruction are logically ANDed, and the result is updated to the direct memory location specified. So in this case the it is based upon the destination location. We are fixing the addressing mode of that particular instruction. So in the last two instructions of ANL, we can see the destination is the direct memory location, so we call that this instruction follows the direct memory addressing mode. Okay, then we have the next instruction set, it is CPL destination, which is used for performing the complement operation on the register specified. So here there is only one location which is going to act as the source as well as the destination. So in this case we are only making use of the accumulator register. So CPL A means the content of the accumulator will be complemented, or the content of the accumulator A will be logically not. Okay, the logical not operation is performed on the content of the accumulator register, and the resultant of value is stored in the accumulator. So in a short means, it means it is going to take the complement of the earlier bits that is present in the accumulator. Okay, then we have the ORL destination comma source, which is just the just similar to that of the logical AND operation, but here the instead of the logical AND operation, the logical OR operation between the two operands are being taking place, and the first four instructions where you can see that the resultant is updated in the accumulator, that is the destination is the accumulator register, and we can have the second operand. One operand will be of the accumulator, and the second operand can be either an immediate data, or it can be content of the register, or it can be the content of the direct memory location specified, or it can be a content that is pointed by the pointer register. So we have the four different addressing modes for these same instruction itself. And the last two, which is similar to the logical AND, here the OR operation is performed and the resultant is stored at the destination location, where the destination location is specified in terms of the direct memory address that is specified in the instruction, so it follows the direct addressing mode. Then we have clear A, where the content of the specified register, that is whenever there is a single register specified, we will be always going for the accumulator register. So if I need to make the accumulator clear, or I need to move or load the accumulator with 00, or the 8 bit should be made 0, then I can use this clear A, which makes the copying of 00 hexadecimal value to the accumulator, or 00 decimal value, both are same. Then we have XRL destination comma source, which is the which performs the exclusive OR operation on the two operands. So the first four instructions of this basic type is where there is XORed resultant operation will be available in the accumulator, or we can say that the accumulator content is underwent XOR of logical XOR operation, exclusive OR operation, with a content either specified in the register, or either specified as an immediate data in the instruction, or specified as a content of the direct memory specified in the instruction, or as a content of the memory pointed by the pointer register. So we have the first four, which basically covers the four different addressing modes, and we have the last two variants of XRL, that is exclusive OR operation, where the resultant is stored in the direct memory instead of the accumulator. So that those two instructions follows the direct addressing mode. So that was regarding where, or till now we have discussed with respect to several instructions which is going to perform some logical operations and update the value of the accumulator. Now let's move on to the instruction that is for rotating. Okay, if we need to rotate the contents, so we have RL rotate left. So RL, so these rotate instructions, RL or RR or RLC or RRC, are basically the instructions which is performed on a single register. And as I told earlier, whenever there is a single register or a single source, and or whenever there is a condition in the instruction where the source and destinations are same, there that register, the source and destination, will be the accumulator register. Okay, so this rotate instructions are only applicable for rotating the content of accumulator. So whenever we need to rotate some value left or right, we need to copy that value to the accumulator, and then we have to perform the rotate operation. Okay, so RLA means rotate left, so the accumulator content is rotated left. That means the D7 is rotated to D0, D0 to D1, D1 to D3, D2, D2 to D3, D3 to D4, D4 to D5, D5 to D6, D6 to D7, and D7 to D0. So likewise you can see there's a left wise shifting. And RRA means rotate right accumulator, that is a 1 bit rotation of the content of the accumulator to the rightwards. Okay, so D7 is rotated to shifted to D6, D6 to D5, D5 to D4, D4 to D3, D3 to D2, D2 to D1, and D1 to D0, and finally D0 will be rotated, it will be right shifted and loaded to D7. Okay, so the outgoing content of D0 is updated to the position D7. So there is a rightward rotation by 1 bit. Okay, then we have the RLC and RRC, where the similar rotations are performed left or right of with respect to the content of the accumulator itself, but in this case the carry flag is also included. So when you are executing RLCA, that means the content from D7 is now shifted left. Okay, so that is outgoing content of D7 bit is now loaded to carry flag, and the carry flag information will be now loaded to D0. Okay, instead of the loading the content of D0 to D7 to D0 in the RL instruction, that is rotate left instruction, here the content that is coming out of D7 is now loaded to or copied to carry flag, and the content of the carry flag is now shifted to the D0 bit. And when we go for RRC, the opposite behavior occurs. You will be rotating rightward, so the content that is going out of D0 will be now loaded to carry flag, and the carry flag content will be now loaded to the D7. Okay, so there is a small mistake here in the slide, so this arrow is just the opposite. Okay, so these are the instructions. We have the logical AND operation, OR operation, XOR operation. Then we have the clearing and complement operation for accumulate register, and we have the rotate left and rotate right instructions for the content of accumulate registers under the uh, logical instruction set supported by 8051 microcontroller. So that's all about the logical instruction set. So in the next class we will be discussing about the bit manipulation or bit oriented or boolean instruction set that is supported by 8051 microcontroller. Thank you.